Okay, so in this video I'm going to start problem from 13.4. I believe this chapter is about the fundamental theorem of calculus, if I have this correctly. Um, so this problem is, if you don't follow through what's happening, it might be a little bit weird. It says the inflow of revenue to a computer company in billions of dollars per year is approximated by this function. So this function is really the rate at which revenue flows in, right? So this is the rate. Let me write that down here. This is important to understand what is this function. It's only worked for x greater than 3, so that's going to be important because the natural log is only defined for positive values of x, so we don't have to worry about the absolute value in here. In part A, it says use a product rule to find the derivative of y equals x times natural log of x minus 1. And this is in general, so it seems like it's nothing to do with the problem. So it has the absolute value of x there. Although for this problem, since we're going to use x greater than 3, we're not going to need this absolute value because x is positive. Okay, now why are they asking us to do A in the middle of this problem? Maybe you got stumbled, like, I don't know what A has to do with B, but okay, let's step back for a minute and say what are we doing? So the fundamental theorem of calculus says that if you have a function on card big F, is a function with the derivative of the function equals to the little f, then if you want to find the integral of the little f between two values, all I have to do is plug in the big function at b minus the big function of a. Right? That's what the fundamental theorem of calculus says. So to solve the question says use your answer part B. So forget about that for a minute. Use the answer forget about that for a minute. It says find the company's total revenue between these 2 years. Okay, so this is the rate at which revenue comes in. So that means that this is a derivative, right? So that's what I wrote this up here. So we need to find a function whose derivative is this function. So this is what the problem is. What's going on? We need to find the antiderivative, right, of little f. And sorry, let me back up a little bit. So this is the rate at which money comes in, and how do you find the total amount of money that's coming in? That is the antiderivative. That is the integral, or the area under the curve between these two values. Okay. So to solve this question, we need to find basically this. So the problem is to find that big F. Okay, so what function will give me this little f as a derivative? Now, okay, so let's see what A does. Let's see if we can connect the dots with A. It says find the derivative of y equals x times natural log, and it says absolute value of x, like I said, because it has to be positive, but if you want to forget about the absolute value part, it's not a big deal for us. So the derivative of this guy would be derivative of this guy. Let me do the product rule. So that times, I'm writing it down, it's pretty easy, but I'm writing it down in steps. Then plus x times the derivative of the second part, right? Okay, so the derivative of x, of course, is just a 1, so this part is just the natural log of x minus 1 plus x. And here, the derivative of natural log of x is just 1 over x. And the derivative of this guy is 0, right? So these cancel. I mean, it's a little bit complicated, but x is going to be positive, so it's going to cancel. And you get natural log of x minus 1 plus 1, right? So now these guys cancel, and you get the natural log of x. Okay, so I'm finding the function. So what we found here is they made us check basically that if you call, let me call it G. I don't know if I can keep more names in here, but if you find the derivative, let me put it this way: the antiderivative of natural log of x is x natural log of x minus 1. That's what we found here. plus a constant if I don't have integration, right? Because here we had backwards, we found that the derivative of this function gives you this. That's the same as saying as the antiderivative of this function gives you that, right? So this is what we're just telling us right now. So they told us to find the derivative, but no, read this backwards, right? The antiderivative of this gives you that. Why do we do that? Because, again, to solve the problem that we're asking us, I would solve part B if they tell us all we need to do is do the integral. Let's read the years. It says x equals 0 is 2000, and we want to do between 2006 and 2009. So it's 3 years. From 6 to 9 of the function 3.5 plus natural log, I think, no, plus 28 natural log of x. Okay, so this is what I need to do. Okay, this is not easy because, well, first of all, you can break it up like this. I can do this. 6 to 9 of 3.5 dx plus the integral from 6 to 9. In fact, I can put the 28 outside. I'm just writing it so we can see how this relates to the top. Right. This one is a piece of cake. This part is fairly simple. This first one. The problem is this part. This is the one that we don't know how to find the antiderivative of a natural log of x. Well, we just did it up here. Okay, that's why they ask us in part A, find the derivative of this function and realize that you actually just get the natural log of x. So now we do know what to do. This part just becomes 28 x natural log of absolute value of x, or of x, sorry. I have to put a parenthesis like this, plus 1, minus 1, sorry. Evaluated from 6 to 9. This part is what I had before. Of course, this is really easy. 3.5x from 6 to 9. Okay. So I did this before, and you just plug in the 9 and the 6. You plug in 9 and 6, and you get the answer that this problem had as in the answer. So I get exactly, if you do this in the calculator, you get a 179.185, but this was in, I believe, in millions of dollars, so this is really 179 million, I believe, or something like that. Sorry, 179 billion dollars. So this is what the person is asking. You need to find, to solve the question, you need to find the antiderivative of this function, but we can't do it because we don't have a nice way to find an antiderivative for natural log of x. But they told us, oh look, you take this function out. This one, if you take the derivative of that one, who knows? Who knew? You really get natural log of x. So they really just gave you the answer, right? You just have to connect those two pieces together and know that's what you're doing. Okay, so I hope this clarifies a little bit how to solve this problem. Okay.